In this tutorial, I would like to show an example of setting up numerical simulations with the Lumerical FDTD solver. This example is probably one of the simplest structures that one can think of, but this type of structure commonly occurs in the field of research related to nanophotonics, plasmonics, and metasurfaces. I mainly work with another package, which is called CST Studio Suite. Because of this, in this tutorial videos, I will briefly discuss the similarities and differences between Lumerical and CST. But I will mention these aspects only briefly. In no way the series of videos related to the comparison of these two different packages. I will provide PowerPoint slides supplemental to this video tutorial. This video is the first out of 10 for this tutorial that describes setting up simplest simulation with Lumerical software. In this short video, I introduce the structure we are going to simulate and emphasize the benefit of using scripts in defining the structure elements. Similar to the case with the CST Studio Suite tutorial, I'm going to show how to set up a structure that includes nanoantenna. I chose a task to reproduce transmission plot shown in this article published in Laser and Photonics Reviews in 2017. I will show how to model a periodic array of spherical nanoparticles and obtain the transmission spectrum the same as in the figures 3a. So the period of the array is 220 and 450 nanometers in the x and y directions, respectively. The incident electric field is along the x direction. In the original article, the simulation was performed with a finite element method. As already mentioned, my demonstration is not a comparison of the methods or software packages. A numerical solver discussed in this tutorial is based on finite difference time domain method, and we often abbreviate it by saying FDTD. The approach used in this example is the same as in many other numerical simulations. To perform simulation of the periodic array, we place only one antenna in the domain and impose periodic boundary conditions of their computational analogy. In the simulation domain, we set up physical objects, which is an antenna in our case. Next, we add substrate and superstrate for correct spacing between the object and the domain boundaries, as well as the convenience of meshing. So alternatively, we can set up only one homogeneous block around the sphere if the substrate and superstrate material properties are the same and we don't need different mention of those simulation elements. We apply domain mesh, define boundary condition, and we add excitation source, field monitors, and so on. So the main emphasis of this tutorial is on how we set up a simulation domain using variables. I will show the procedure of setting up the variable for a number of simulation characteristics of the domain, including dimensions of the object, excitation source, mesh, and field monitors. I will show step by step how we write a script for each of these structural elements. An alternative option for simulation setting is simply to put numbers directly in the dimension boxes. But this approach can create many problems if we need to change any of the dimensions later in the process of simulations. Each time we need to change one number such as object dimensions, we have to go through all structure elements one by one, open those setting boxes, and manually change the number in each box. This process may take a lot of time and introduce more errors in the simulation settings. The correct way to set up simulation is to introduce a list of parameters and define all structure elements using those parameters. We often call it a dashboard, and I discuss it extensively throughout my lecture course in the concept of MATLAB programs and CST Studio Suite simulation. In this tutorial, I'm going to show how to introduce a parameter list and use it in the scripts for different structural elements. This completes an introductory video on numerical simulation with the Lumerical FDTD tool.